Hello, I am Madam Gracious Kanzini from Educare TZ. Warmly welcome my online students so as we can make the tutorial on our advanced level. And here my students, we are going to make tutorial on our chemistry subject, and I have said that we are making the tutorial for advanced level. So here we are going to have the tutorial on Form 5. And in our chemistry subject, we have our main topic, which is general chemistry, which have the two main subtopics, the concept of atom and the chemical bonding. My students, I am sure that once you are in Form 2, Form 3, Form 4, this concept is not new for you, but here we're going to look in a broader way. That's why it is advancing. Okay, in our subtopic, which is the atomic and this chemical bonding, we have the several subtopics within it. So we have to make a coverage in the atomic, and finally we are going to look on the chemical bonding. So as here we are proceeding with the the first subtopic, which is the atomic, and we have this several subtopic. In the atomic, we have the main four subtopic, which is the concept of Dalton atomic theory, the concept of Bohr's atomic theory, the concept of atomic mass, and finally we're going to look on the issue of the quantum theory. As in the previous session, we have already looked on the Dalton atomic theory, which is the major foundation for all scientists to discuss or to come with the further ideas toward the concept of the atom or the structure of the atom. Now we are in the concept of Bohr's atomic theory. But in the Bohr's atomic theory, he tried to come up with the kind of the spectral line, the kind of energy, the kind of radiations or electromagnetic radiations. And my student, in a previous session, we tried to look on the nature of electromagnetic radiation. And one among of the example of electromagnetic radiation, we try to look on the concept of light. Tukaona kwamba light ana display some features or some properties which behaves like the wave or those electromagnetic radiation features. So here today we are proceeding to look on the general overview, which is all about light as electromagnetic radiation. Why? Na ni kwa namna gani? So there is some of the properties which he proposed after this identification or this assumption that light is one of electromagnetic radiation, and it have some of the same property or similar property with wave particle. So here, my student, we are proceeding, and we can say that it was generally accepted that light behave as waves because of its observed wave properties. Hasa tulisema kwamba light is one of the electromagnetic radiation, and when we come in the electromagnetic radiation, we can see the properties of wave. So here tunakuja ku generalize kusema kwamba the light behave as wave. Why? Because of its observed wave particle. So here there is this properties. The observed properties of light, it is similar to that of the wave. And the final, these scientists come up with the general acceptance or general conclusion of that light behave as a wave. So my students, you can see that later on, the three properties involving the matter and the light lead to the deduction of the particle nature of light. Deduction of particle nature of light. The only three properties. Kwamba at the end of this assumption of these ideas, of this observation of these properties of wave and light and look like the same or similar, there are development of three properties involving matter and light. And these particle natures, obvious, it led to the development of the modern atomic theory. Remember, the Dalton atomic theory tried to come up with the idea toward the atomic structure. And finally, the different experiments was conducted and the new ideas raised. For instance, tunaona kwamba zile earlier assumption of the Dalton atomic theory, there are a modern one. And this modern one is all about the atom that is made up of those subatomic particles, and the different scientists try to come up with their idea. How do this arranged in the atom? But you can see that through this Bohr's atomic model or atomic theory, this concept, ambapo alikuja na issue of light or this nature of electromagnetic radiation, you can see that there is this deduction of the particle nature. The properties of light seems to be seems to have the similar properties of that of wave. And now, what are those properties? So these phenomena are emission of light by solid object when heated. Another one is photoelectric effect, and the last one is atomic spectra. So we have only three properties ambazo zilikuja kuwa deducted as a nature particle. Nature particle. In other way, you can say wave particles or light particle. So you can see that the first one is the emission of light, kwamba kunakuwa na light tend to be emitted once the object, na hiyo object lazima iwe ni solid in nature. Solid in nature mean that the object will emit, the light will be emitted when the object is passed through the discharge tube or once it is subjected to the heat source, kwamba kunakuwa na emission of light. Kwa hiyo ndo main. But also there is the issue of photoelectric effect. Photoelectric effect mean that the same, kunakuwa na hizo kind of radiations. As you see, there is the word photo. This means light, but there is the word electric effect. So I mean that kutakuwa na hiyo relationship with the what? With the radiation. But also there is atomic spectra. We are going to see more what is atomic spectra, what does it mean in detail. So these are the main three properties which are suggested toward the nature particle. Okay, so it was observed that when a solid object is heated, it emits visible light, of which it is intensity and color change with temperature. Asa ile, kumbuka tunaongelea zile three properties baada ya those scientists come up with the deductive of the nature particle. So tumeona kuhusiana na emission, phenomena of emission. So how do emission occur? Tumeona kwamba ile solid object, when it is heated or it is subject to the heat source, it observed that it tends to emit visible light. And remember, visible light are kind of light which you can observe. That's why it's called visible. How can you observe it? You can observe the color, you can observe their features. That's why anasema kwamba it tends to emit the visible light, of which it is intensity and the color change with the temperature. Mean that it tends to display some of the colors depending on the temperature ambayo itakuwa ina favor ile heating condition. So this Max Planck developed an equation that led to the explanation of the particle nature of light and the quantization of energy. Max Planck, huyu ni scientist. Kumbuka nikwambia kwamba the scientists, they tend to raise their idea depending on the major foundation of the Dalton assumptions. Kwa hiyo huyu Max Planck developed an equation. Yeye akaja na equation ambayo ile equation obvious anasema it tend to explain the particle nature of light. Particle nature of light and quantization of energy. Particle nature of light and quantization of energy. Quantization of energy. He proposed that a heat object could emit or absorb only a certain quantity of energy which is directly proportional to the frequency. Hiyo ndiyo alikuja kudrive equation yake kulingana na hii idea kwamba heat object could emit. Sasa tumesema kwamba ile emission inatokea pale ambapo the solid object imekuwa subject to the heat source. Sasa yeye anakuja na condition au anakuja na fact kwamba the heat object could emit or absorb, kwamba ita emit au itafanya absorption only a certain quantity of energy which is directly proportional to the frequency, kwamba the energy will be directly proportional to the frequency. Kumbuka tulisema light behave as wave, kwa lazima tuone issue za frequency, wavelength, lazima tuone hizo property. Ndio maana there is deduction of particle nature au wave nature or light nature, particle, whatever. So, and this equation was shown in the equation number 1.4 ambapo aliona kwamba kunakuwa na direct proportional, the direct proportion between the energy and the frequency of the lighting. So this equation is as follow. As you see, energy is direct proportion to this symbol is like V, lakini unaiandika katika namna ya italic fulani V. So this represents the frequency. Sometimes you can see that some teachers, they tend to demonstrate the frequency as F, au hata some of the book au some of the resources, they tend to demonstrate the frequency, they represent it by using F, a small letter F, whatever the case. Kwa hiyo utakuta sometime wanatumia this letter V, lakini pia sometime unakuta anatumia small letter F which denote which demonstrate the frequency. So this Max Planck alikuja na hii equation akasema the energy is directly proportional to the frequency. Energy is directly proportional to the frequency. So in order to remove this proportionality sign is where we can say that energy is equal to HV. HV. So what does H mean? We can see that where H is the proportionality constant called Planck's constant. Called Planck's constant. And its value is known as 6.626 times 10 power negative 34 joule second. My student, hivi vitu ambavyo tunavisoma huku sometimes vinakuwa katika like explanation, ni just the prior understanding for you to understand in the complex one, kwa sababu tunapoendelea mbele tutakutana na complicated concept ambazo most of them zina involve the calculations. So you can't able to attempt those clearly if you are not understanding this concept from the simple one. Kwa lazima tu demonstrate vitu vidogo vidogo huku ili tunavyoenda mbele uwe una ile ule ufahamu wa mwanzoni kabisa. So this is the equation now, kwamba energy ni sawa sana h frequency. So you have to master this equation. Na hii Planck's constant, hii value ipo constant ambayo value yake ni hii. Kwa hiyo wherever in your calculation utaitumia hii value ya 6.626 times 10 power negative 34, lakini lazima ukumbuke the SI unit. SI unit is joule second. Joule second, tunajua joule is for energy, second is for time. So it was later proposed that the color of hot object is caused by the emission of radiation from atoms contained in the object. Asa ile tuliona kwamba ile emission inakuwa observed with that color. kunakuwa na zile features za color depending on the temperature. Therefore you can see that it was later proposed that the color of hot object, ile hot object sasa ambayo ni solid, is caused by the emission of radiation from atoms contained in the object. It means that that object, it have some atoms. It have some atoms. So the atoms within or contained in that object ndiyo ambayo ina display a certain color once it is in hot. Ndio utakuja kuona kwamba kuna rangi maybe red, whatever the kind of color. Utakuja kuona katika issue zima ya the spectrum, utakuja kuona hizo colors zinavyokuwa displayed. So if an atom can emit only a certain quantity of energy, that means there is a specific quantity of energy that is present within the atom. Kama atom itaweza kuemit a specific kind of energy, kwa maana hiyo ni kwamba within the atom there is a specific energy. Each atom, yani kama atom can emit only a certain quantity, yani kiwango fulani tu, yani inafanya emission ya kiwango fulani tu, only a certain. Kwa nini not all? Or why yani just only a certain of energy? Here, what does it mean? This means that there is a specific quantity of energy within that atom, kwamba kila atom ina specific energy yake. That's why ndo maana hata emission ina take place in the certain, only a certain kind of energy. Therefore the energy of an atom is quantized. The atom of energy is quantized. I mean that not continuous, is quantized, not continuous. And this quantization or quantized of the energy, it is in a discrete packet of energy called the quanta. Discrete packet of energy called the quanta. Kwamba hii energy ambayo tunasema kwamba it is quantized ipo kwenye specific au tunasema discrete packet ambayo tunaita quanta. Tuende kusoma zaidi kwenye mambo ya quantum, tutaona zaidi kuhusiana na hizi quantization of energy whatever, kwa sababu una kabisa hicho kipengele au iko kipati kuhusiana na quantum theories. So the discovery led to the support of the particle nature of light as explained by Albert Einstein in his photon theory ambayo ni photoelectric effect. Kwa hiyo tunaona kwamba his concept, every scientist try to come up with the idea depending on the different experiments which are conducted. Kwa hiyo tunaona kwamba the discovery led to the support of the particle nature of the light as explained by huyu Albert Einstein. Naye alikuja na yeye pia na assumptions zake au na idea zake, naye alijaribu kufanya discovery ambazo zilisupport this particle nature of light. Na hii kumbuka ilianzia pale ambapo tulianzia kuona nature of the electromagnetic radiation, ambapo tuliona kwamba the light is one of the electromagnetic radiation and it seems to have the similar property with the wave, and therefore there is deduction of this nature particle or particle nature of light is where deduced. So this Albert Einstein as usual alitumia this photon theory au photoelectric effect theory yake kuja kuelezea hii concept. So photoelectric effect is the ejection of the electron when light of sufficient energy hit a metallic object. Bado tunaongelea ile the way ile object inavyo emit radiation once inavyokuwa subjected kwenye heat source. Kwa hiyo hii photoelectric effect is the ejection of the electron when light of sufficient energy hit a metallic object. We are going to look on the figure 1.11 whereby Einstein deduced that the photon of light beam have a characteristic energy, kwamba a certain light or a certain beam of light have a characteristic energy which is determined by the frequency of the light. So in an electron, if an electron absorbs enough energy than the minimum required threshold level, it is ejected from the material. Sasa kama kutakuwa na this absorption of this kama electron absorb enough energy than the minimum required, therefore the threshold threshold level, it is ejected from the material.